All right, so this begins the first initial topic in a long series of topics that relate to rate of change, and we're going to be talking about average rate of change today. And so, a really important concept you got to understand throughout the entire year in calculus is that whenever you see this term, rate of change, you should always associate that with the slope of a line. That's how we're going to come up with a graphical interpretation of what rate of change is. An average rate of change, when we stick this word right before rate of change, that means a very particular type of slope. Instantaneous rate of change means an even another type of slope. So let's talk about this one first, though. But if I was going to go and ask an Algebra 1 or Algebra 2 student, hey, what is rate of change or what's the slope of a line, they should tell me, oh, well, that's just rise over run. All right, and now if you look down at this coordinate system right here, we have 2 points, x1 comma y1 and x2 comma y2. So if you were going to calculate rise over run from this, you would say, oh, okay, well, that's going to be just y2 minus y1 over x2 minus x1, all right? And so we're going to still describe this in this way, but I want to introduce a Greek letter called delta, this one right here, which will help us describe it a little bit more of a shorthand form. What delta means is it means big change, okay? So what that means is some final value minus some initial value. An example is that if I'm going to speed up from 50 miles per hour to 60 miles per hour, well, that means I need to speed up by 10 miles per hour. That's the change I need to go from 50 to 60. So if I wanted to calculate that change, that would be my final value, which would be 60, minus my initial would be 50. That would give me my change, which would be 10. Okay, that's an example of what final value, initial value, and change means. Now we can express our change in y or our rise and our change in x or our run using that same type of thing, final value minus initial value. So another way we can write average rate of change is just going to be our change in y over change in x, okay? All of these things that I wrote down right here mean the exact same thing. There's just 3 different ways to write it, okay? So again, in Algebra 1 or Algebra 2, you guys would have used this to say calculate the slope of a line between these 2 points and eventually an equation of a line that goes through those 2 points, all right? We're going to use a little bit different things when we talk about calculus here. So let me go to a PowerPoint slide which illustrates this a little bit more. So first of all, I apologize. For some reason in this Smartboard software, I'm not allowed, or it's maybe when I record in QuickTime, I'm not sure. I'm not allowed to go full screen on my slides, so you'll just have to deal with the small view. But let's say we got this function, we call it f of x. We're going to put an initial x value, which will be a, and a final x value, which will be b. Those will have a corresponding initial y value and final y value, f of a and f of b as well. If I want to look at my change in x values, which we'll call delta x, well, again, that's just going to be final minus initial. Our delta y, or delta f in this case, is again just going to be final minus initial, but that's going to give us essentially this, again, is going to be our run. This is going to be our rise. So we can use this rise and this run between these 2 points right here to calculate an average rate of change of f of x between those 2 points, all right? So if we want to calculate that average rate of change, again, we're really just going to look at doing rise over run, okay? So in this case, that would be delta f over delta x, or f of b minus f of a over b minus a. This right here is the equation you want to memorize if you're going to memorize anything for average rate of change. That's all it is. But again, this equation is really just saying rise over run. Okay? Now I'm saying rise over run a whole bunch of times on here, repeating myself, because when we get into instantaneous rate of change, this concept of rise over run is going to help you understand that really, really, really well. Okay? So if we talk about graphically what an average rate of change means, well, an average rate of change is really just a fancy way of saying what is the slope of the line, in this case this line connecting these 2 points, that connects those 2 points. The average rate of change is not the equation of that line. It is just the slope of that line, okay? Sometimes we refer to it as the slope of the secant line connecting the points A, f of A, to B, f of B, all right? So let's talk a little bit more conceptually about what average rate of change means. And to do that, I'm going to use this Desmos file right here. So in this file, I got a function, the red line, which is just some parabola I made up. I got an initial and starting point, A equals, whoa, oops, sorry about that. I got an initial and starting point, A equals 0, B equals 3. And what we're going to do is I put two black colored points right here. This would be A, F of A. This would be B, F of B right there. And you see that I've created a blue line between those points. Now, if I ask you right now, hey, what do you think is the slope of that blue line between those 2 points? Conceptually, what does it mean? You should, from the last PowerPoint slides we saw, say, oh, that's just the average rate of change between those 2 points, all right? But really, what does average rate of change mean? Why would we calculate it? And so to do that, what I'm going to do is go down here. I've made this thing right here, x sub I, which is just going to take on any x value between the values of a and b, which are 0 and 3. And I'm going to animate that and show you guys that if we put a dot, we'll put a blue dot for the blue line, a red dot for a red line. If we were going to follow a point that corresponded to these x values given by xi, notice what happens when we animate this, and it might give you a bit more of a conceptual understanding of what average rate of change means. All right. So if I animate this point, again, you see a blue dot following the blue line and a red dot following the red line. All right. What things do you notice? All right. One thing you should notice instantly is that they both start at the black dot representing A, F of A, and they both end at the black dot representing B, F of B. But the way in which they go there are two different ways. The red dot goes through varying changes in its y values. So for example, when the red dot is moving up here, it's changing its y values at a much more steep rate than what the blue line is. When it gets to be right here at the top, it changes its change. So instead of going in a positive y change, it starts going negative. And here it starts going down. Whereas if you look at the blue dot, it just goes in a consistent, never-changing rate of change to get from that one black dot to another black dot. And so that's really what the difference is between average rate of change and what we will call instantaneous rate of change. Average rate of change just says, okay, get me from the first black dot to the second black dot using the exact same increments of change in our y values to get there, whereas the red dot says, hey, I'm going to get to that exact same point in the exact same time, but I'm going to do it using varying levels of change, and those varying levels of change are what we call instantaneous rate of change, right? We'll go over this in a bit more detail in class. I'll go over this Desmos graph right here. So if you're still a little bit confused about it, ask questions. Come tomorrow in class ready with questions about this Desmos plot right here, okay? So let's finally go over a couple problems. How do we solve problems using average rate of change? All right, so let's go over this one first. So this one says, what is the average rate of change of this function right here over this interval from 0 to 2? Okay, well, try to solve this on your own based on what we found in the last couple minutes of this video. Pause the video right now, try to solve it. All right, so if you've gotten back to it, hopefully the first thing you noticed is, well, average rate of change, okay, that's always going to be f of b minus f of a over b minus a. But in this case, a is 0, that's our initial point, and b is 2. So therefore, if we just plug these things in, that's going to be f of 2 minus f of 0 over 2 minus 0. Well, what is f of 2? Well, to find f of 2, we just plug it into this equation right here. So that's just going to be 2 squared plus e to the 2, which is going to give us 4 plus e squared. And f of 0 is 0 squared plus e to the 0, which is 1. Ooh, who said that e to the 0 was 0? Shame, shame. Don't ever do that. That's very bad. All right? So if we plug this in, we're going to get that the average rate of change in this case is going to be 4 plus e squared. Again, that's my f of 2 minus 1, which was my f of 0, over 2, and that's what it is. All right? Graphically, if we drew these points 0 right here, and 2 is going to be up around here somewhere, what we're calculating is the slope of that line connecting those 2 points. Okay? That slope is what this value is right here, and that's our average rate of change. All right? So let's go on to another example, which is a bit more conceptual and kind of plays on some of the things we've talked about as it relates to rate of change. So if we go to this next example, we see a little bit different, okay? Now we're given a bit more of a real-world context behind this thing. So it says we got a position of an object moving along a straight line is given by this formula, S of t right here. And it says, what is the object's average velocity from t equals 1 to t equals 4, okay? See if you can answer this. Pause the video right now and see if you can answer this on your own. All right, so if you've tried this, hopefully you've noticed the little trick in this, which is why I said this is going a little bit more conceptual. We're talking about position and velocity. And what we've learned so far is that velocity is the rate of change of position. So if we're asking for what is the average velocity, we're really asking for what is the average rate of change of position, all right? So that is simply going to be S of 4 minus S of 1 over 4 minus 1. Again, t equals 1, that's going to be our value for A. T equals 4 is going to be our value for B. So if we plug this in, we'll get that S of 4 is going to be 2 plus 4, 2 plus 4, not 4 squared. So 2 plus 4 minus 4 squared. That'll be 6 minus 16, which will be negative 10. And if we evaluate S of 1, that'll be 2 plus 1 minus 1 squared, which is just equal to 2. So if we plug all these in, we will get this is going to be equal to negative 10 minus 2 over 3, which will give us negative 4. Okay, that's going to be our average velocity to get from those 2 points. All right, if we look at these 2 points of t equals 1 to t equals 4 will be somewhere down in here. Again, what we're doing is we're calculating the slope of this line. We're finding out that that slope is going to be negative 4. And again, what this is saying is we have 2 options, okay? We can either follow the red line dictated by this function s of t from t equals 1 to t equals 4, that's 3 seconds. So it's saying, okay, start at this initial point right here, and in 3 seconds follow the red line. You're going to end up at this final point right here. Or you can take option number 2. You can still start at that point, but instead of following the red line, you could just move at an average rate of change of negative 4 units, whatever distance units we're using per second. And at the end of that 3 seconds, you would end up right at that final point at the exact same time the person that moved along the red line would have taken to get there. Again, that's the difference between instantaneous rate of change and average rate of change. In the next video, we will talk in more detail about instantaneous rate of change and how it relates to something called the derivative.